Welcome to It's Good to Be Smart. I'm your host, Dr. Dave Mulder. I love to learn new things, and I hope you do too, because it's good to be smart. Today, we're taking a journey through space and time to meet a scientist who helped us measure the universe. Yep, the whole universe. You may not have heard of Henrietta Leavitt, but her discovery changed astronomy forever. And she did it at a time when women weren't even allowed to look through big telescopes. So buckle up, we're headed into deep space. How do we know how far away stars and galaxies are? I mean, it's not like we can stretch out a giant ruler into space, and GPS doesn't exactly work light years away. Wait, what is a light year anyway? The word light year might sound like a way to measure time, but it's actually a measurement of distance. A light year is how far light can travel in 1 year. And light is fast, like super fast. Light moves at around 186,000 miles per second. That means in 1 second, light could go around the Earth more than 7 times. So in a year, light can travel about 6 trillion miles. That's a 6 followed by 12 zeros. So why do we need such a huge unit to measure distances in space? Well, to put it simply, space is really big. I mean, it's really, really big. Our own galaxy, the Milky Way, is about 100,000 light years across. And remember that a light year is something like 6 trillion miles, which means, well, that's a lot of miles just to get across our galaxy. What I'm saying is this: even if you could travel at the speed of light, it would take you 100,000 years to get from one side of the Milky Way to the other. And you know what else? The Milky Way is just an average-sized galaxy, and there are a lot more galaxies out there. In fact, scientists have found that there are billions of galaxies in the universe, and galaxies are often millions of light years away from each other. So, yeah, space is really, really mind-bendingly, gigantically big. Okay, now, back to the question. How do we figure out how far away things are in space? That brings us to the hero of today's story, Henrietta Leavitt. Henrietta Leavitt worked at Harvard College Observatory in the early 1900s. But she wasn't officially called an astronomer. Nope, back then she was hired as a computer. And that was the actual job title for people, usually women, who were paid to do calculations, not to do original science. But Henrietta had other plans. She was assigned to study a special type of stars called Cepheid variable stars. Sounds fancy, right? Let's break it down. Cepheid variables are stars that pulse. That means they get brighter and dimmer over time, kind of like a lighthouse or a blinking light at the top of a tower. The important thing is that they don't blink randomly. They have a steady pattern. Some pulse faster, some pulse slower. Henrietta looked at thousands of these stars by studying photographs of the sky. And here's where it gets amazing. She noticed a pattern. The stars that took longer to pulse, say like 10 days, were brighter than the stars that pulsed quickly, like every 2 days. In other words, the brightness of a Cepheid variable star is connected to how fast it pulses. Now that might sound simple, but this discovery was huge. It meant that if you saw a Cepheid variable star and measured how fast it pulsed, you could calculate how bright it really was. And once you knew that, you could compare it to how bright it looked from Earth and figure out how far away it is. It's like knowing how big a light bulb is and using how dim it looks to tell how far away it must be. This gave astronomers something they really needed: a cosmic measuring stick. Henrietta's discovery was picked up by some other astronomers, most famously Edwin Hubble. Yep, that's the guy the Hubble Space Telescope was named for. And using Leavitt's method, Hubble found that some galaxies were millions of light years away. Even more amazing, he realized that galaxies were moving away from each other. And this led to one of the biggest ideas in astronomy. The universe is expanding. That means it's not just huge, it's getting bigger all the time. Think of the universe like a balloon. If you draw dots on it and then blow it up, the dots move away from each other as the balloon gets bigger. That's kind of like what galaxies are doing in space. But none of that could have happened without Henrietta Leavitt's discovery. Without her work on Cepheid variables, we'd still be guessing about distances in space. Henrietta Leavitt didn't win any big awards in her lifetime. She didn't even get to use the telescope she helped make so important. But her work gave astronomers a way to reach across the universe, to measure it, map it, and understand it. She taught us that even in a sky full of blinking stars, there's a pattern waiting to be found. And finding that pattern could change everything. Sometimes the biggest discoveries don't come from loud explosions or rocket launches. Sometimes they come from quiet patterns, careful thinking, and someone brave enough to keep asking questions. Henrietta Leavitt showed us that. And because of her, we know just how vast and incredible our universe really is. Thanks for joining me for this episode, and nice work leveling up your brain power today. Remember, smart isn't something you are, it's something we become as we're learning. So keep listening, keep learning, and keep getting smarter every day. It's Good to Be Smart is created and produced by me, Dr. Dave Mulder, with the support of the National Science Foundation through the Robert Noyce Teacher Scholarship Program. Subscribe to this feed so you'll never miss an episode. And check out our home on the web, goodtobesmart.com. Until next time, keep asking questions, stay curious, and keep learning, because it's good to be smart.